And my mom was actually in prison when I was born. So immediately I was put into foster care. So I was like, all right, the fourth year of my PhD, maybe the last year of my PhD. In the course of 6 months, I went from 0 papers published to 4 papers published. Embeddings will be able to process any form of unstructured data. The future is multimodal.
Welcome to The Edge of Infinity, a podcast of builders talking to other builders in the AI space. Together, we discuss where the field is at today and make predictions about how things are going to look like in 5, 10, 100 years' time. I'm your host, Lena Avancini-Colucci. Thanks for joining me as we imagine the future of AI together. Hello, everyone, and welcome to another episode of The Edge of Infinity. Today, I am so excited to share with you my conversation with Dr. Cody Coleman. Cody is one of the most inspiring people that I know. His personal life journey is incredible, from being born in prison to getting his PhD at Stanford, and now founding and being CEO of one of the top AI tech companies in Silicon Valley. We have a super far-ranging conversation from the nitty-gritty of his PhD research and what Coactive does today, through talking about predictions for the future of AI and embedding spaces, all the way to what it's like to be a minority in engineering and a minority in the startup world, and both of our personal strategies for having dealt with that in our life. Without further ado, I hope you enjoy my conversation with the one and only, the amazing Cody Coleman. Cody, welcome to the show.
Lena, thanks for having me.
So I wanted to start at the beginning. I don't always like to start at the beginning, but in this case, I feel like your story is so inspiring and incredible. You were born in prison while your mom was incarcerated. You then went and graduated from MIT, which is where we met. You got your PhD from Stanford. You're now the co-founder and CEO of one of the top AI tech companies in Silicon Valley, with top investors. Let's just start by giving the audience, what is the spark notes of your life story and where you're at today?
Well, first off, thank you so much for saying that, we're like a star in Silicon Valley. It's kind of crazy to think, and the journey, you're kind of heads down all the time, but I feel so grateful for kind of how far I've come and everything and being in this position today, because I came from a super humble background, as you mentioned. So, my father left before I was born. I still don't even know his name. And my mom was actually in prison when I was born. So, Monmouth County Correctional Facility. So immediately I was put into foster care and then adopted by my maternal grandparents. And, after a year in prison, my mom's charges got dismissed. And my grandparents being, the people that they are, they have this big, kind heart. They're like, yes, of course, she can come live with us. But she, all of her life, she struggled with mental illness. And that continued, growing up. So it's kind of a constant source of chaos for me growing up. We're, over the 24 years that we lived in the house that I grew up in, we racked up something like 65 police reports. So it was just kind of a super crazy environment. And we really didn't have that much. My mom, again, she just collected welfare. My grandparents collected Social Security and stuff like that. And for me, the environment, it was just about survival. Even at home, my mom, she loved cats and dogs and had this dream of starting her own pet store one day. But the only problem is that I'm actually allergic to cats and dogs. So literally every single day at home, I was sick. It was literally just tough on my body. And for me, going to school was a breath of fresh air. It was really kind of the only way that I could see myself kind of escaping that. And I loved video games. I started out, playing video games as kind of an escape to get away from it all. It's funny to think now that when I thought of NVIDIA back then, it was about their GPUs and getting the latest GPUs so that I could play the kind of newest game and things like that. And that's kind of followed me this entire time. But yeah, school and technology were kind of the escape for me. I was glued to the Science and Discovery Channel, loved computer science, or loved computers. And then, when you apply to college, I was there's this whole thing called the Common App. And they were you got to select a prospective major. And I was like, oh, here's this drop down. And lo and behold, there's this amazing major called computer science. My two favorite things in the world combined together. And I was like, of course I'm going to choose that, But I stumbled upon MIT because of the fact I was like, you go to the College Board, you look at like college rankings, and for computer science, MIT was number one. And I thought, and I thought there was no chance I was going to get into MIT or a place like that, but I figured I would just, give it a shot. And sure enough, got into MIT. I was the first student from my high school to go there, which was crazy. It's actually funny. That's where I met my co-founder, Will, was actually at a program right before MIT. Yeah. Yeah. It was this program called Interphase. It was for students that came from low income backgrounds. And honestly, Will should be the poster child for that program because he met his wife there and he met me there. So it's like he won through that program.
The two most important people in his life.
Yeah, exactly. And then, it was kind of like, at first you get into a place like that and you're just like overwhelmed. You're like, wait, what have I gotten myself into? I'm like here with like the smartest people in the world that you can imagine. And I'm like this little kid from New Jersey, like, how am I possibly going to keep up? So I had like, this imposter syndrome and just, but like, I was like, I'm going to do it. And like, if there's any resource that I can take, like any resources that they have that are offered, it's meant for someone like me. So just kind of went after it.
Something that struck me from your TEDx talk is you said that you were bad at math as a kid. Is that true?
Oh yeah, I was only kind of average at math as kind of a kid growing up, like especially in elementary school, because like, my family, even though they had big hearts, like my grandmother only had like a fourth grade education. My grandfather only had a second grade education. My mom didn't go to college. My oldest brother, Sean, he had dropped out of college. So it was partially like no one really cared about academics. So I didn't really like kind of push myself until I got into high school. And that's where I realized like, that was kind of my opportunity out, was like through school. I wasn't athletic. I wasn't, musically talented or anything like that. So I just was like working hard in school was kind of the only way that I could get out. And it's actually a little crazy now. Fast forward to like finishing up my PhD, I'm turning 30, and I always struggled with reading and writing as well. And I was like, there's got to be something here. And I, right before I finished my PhD, I decided to get tested for dyslexia at Stanford and found out that, after 30 years and 3 degrees, that I was dyslexic.
No way.
Yeah. I would not have done a PhD if I had known that I was dyslexic.
But you didn't know. So you were just like, I'm just going to keep, trying harder and like, just, make it work. This is what I want to do. So let me just figure out a way to make it work. Yeah,
exactly. That's kind of like just like the story of my life is like, figure it out, I actually have this one memory from like growing up. It's like both it was probably a sad memory at the time, but it's also kind of like, I think like summarizes my life. I remember the moment when my mom, she was very nomadic and she just like left one day when I was in middle school. And it was like the morning and she's like, I've had it with your grandmother. I like can't take it anymore. I'm going to move to New Mexico. And, as a middle schooler, I'm like, but like, what am I supposed to do? Like, how am I like, what am I supposed to do? And, my mom responds, and I'll never forget, she's like, you're smart. You'll figure it out. And, I think that's kind of been like the tagline of me in every kind of chapter of my life, whether it's been like MIT and undergrad or doing the PhD or, even now in starting a company.
Amazing. And why did you get a PhD? Did you know you wanted to start a company and that was kind of the path to start a company? Was it you loved academia and wanted to do research? Like, why'd you get a PhD?
It's kind of funny because like I never imagined that I would get a PhD. You know, I thought that in order to get a PhD, you had to be some genius. You know, like I was like, I had to be like you, Lena. You know, you're like a genius. You're a PhD, MD, and I was like, there's no way that I'm in this world where like I would be someone that could get a PhD. But what actually ended up happening is that at MIT they have this Master's of Engineering program, a co-term program. And after undergrad, I just wanted to do kind of more advanced classes. You know, in particular, I was like, there's this thing called machine learning, and there was this graduate course on machine learning. I think it was like 867 or something like that. And I was like, it'd be fun to take like another year and take some like classes like that. So I was like, yeah, let me do the Master's of Engineering. And then it was funny. This was right around the time that machine learning was being applied to education. And I was like, wow, you know, that's like so fundamental, because if we can like, or I guess, sorry, it was digital learning. And it was so fundamental, like the notion that you could actually take this like, you know, educational experience that I had that kind of transformed my life and scaled it up to so many more people. I was like, oh my gosh, I gotta do this. So I decided to do my Master's of Engineering and like do machine learning applied to education. And I'll never forget my advisor, Isaac Schwung. I like came in one day and I was talking to Ike. That's what we called him. And I was like, I had some ideas about research. You know, I was doing like latent Dirichlet allocation applied to like user modeling and stuff. And he's like, I came in during like that one-on-one. He's like, Cody, you should really apply to PhD programs. And, you know, my first reaction was like, he's just being nice. Like me, PhD, I'm not a genius. There's like, it's the requirement for you to do a PhD is you have to be a genius. That's not me. So I was like, he's just being nice, you know, it's like cheap labor or something like that for him. A couple of months later, I came back with some more ideas and he's like, Cody, you should really apply to PhD programs. And, he's like, if money is an issue, I'll pay for you to apply to 4 schools. And I was like, wow. He's serious about this. Like he like thinks that I could do it. And he's putting his money where his mouth is on that. And I was like, there's never going to be a better kind of time or opportunity for me to apply. And then he also lied to me. What he told me was, he was like, the hard part about a PhD is getting in. And like, just because you get in, it doesn't mean that you have to go. And just because you go, it doesn't mean that you have to finish, you know, it's super flexible and stuff like that. I was like, why not? You know, let's do it. So I ended up applying to 4 schools, and I lucked out and I got into all of them. And then, you know, I decided to go. And,
so why did he lie? What was the hardest part? Is that what he lied about? Or did he lie about the fact that once you start, you don't necessarily need to finish?
It was that. It's like once you start that you don't necessarily need to finish, because I was like, yeah, you know, I'll go and try it out. At least like I will have 0 regrets if I start the PhD. And then if I don't like it, I can leave. But my like personality is to not give up, you know, in a sense. So I started the PhD. First year of the PhD. It's great. You know, you're figuring things out. Second year of the PhD, I was like, man, you know, like, what am I doing? Like other people have published papers already. I like don't have any papers. I had like this one workshop paper. And then like the third year of my PhD, like, which is like the existential crisis year, I feel like universally for PhD students, I'm like, what am I doing? I still haven't published any papers. You're in this kind of like dark tunnel effectively where you can't see the light at the end of the tunnel. And I thought about dropping out of the PhD. You know, Ike's voice came in. He was like, yeah, you know, just because you start doesn't mean that you have to finish. But I did a lot of soul searching and talking to people. And I was like, you know, I can't give up that easily. Like, I'm going to give it one more year and I'm going to go all out and put everything in it so that I have no regrets in a sense. And then if it doesn't work out, like I'll have no regrets and I can go back into industry. So I was like, all right, the 4th year of my PhD, maybe the last year of my PhD. And it was super hard. It was super tough. But in the course of 6 months, I went from 0 papers published to 4 papers published. And by the end of that time, I was on track to graduate.
Wow. And how many years did it take you to graduate? Was it 4 or like 4.5?
So it took me 5 years to graduate. I always wanted to graduate in 5 years because, at the end of 5 years, I was going to turn 30, and I was like, I don't want to be in school past 30. But it was funny, at the end of that fourth year, maybe taking a step back, I was advised by this guy named Matei Zaharia. He's well known for creating Apache Spark and Mesos, and is a co-founder and chief technologist at Databricks. And again, I was laser set on graduating in 5 years. So every single quarter I'd come to Matei and I'd be like, hey, am I on track to graduate? So at the end of my fourth year, I came to Matei after I published all these papers and stuff like that. And I was like, hey, Matei, am I still on track to graduate in 5 years? And Matei was like, you could graduate right now if you wanted to. And I was like, thanks, Matei. I'm not going to do any more research, and instead I'm going to focus on what do I want to do with my life, and I always had this dream of starting my own company. So I kind of took the last year of my PhD effectively as a little incubator or accelerator in a sense, or just kind of a retreat, kind of like an opportunity to figure out what do I ultimately want to do, because I always dreamed of starting my own company one day, but I never thought that it was possible. But step by step, over the years, I kind of broke down those barriers that I had and demystified the process. And being advised by someone like Matei, who took his PhD research and successfully converted that into a massive company. And I was like, this is my advisor. And at the end of my PhD, I was like, I'm a world expert in something. There's something that I know more than Matei. I was like, maybe I can do it. Maybe I can start my own company. So.
So cool.
That last year, yeah.
Yeah, that's amazing. It's interesting you said you kind of switched gears, and you're in your fourth year, you switched gears, and it was this might be the last, let me give it my all. I mean, for me, it took me 6 years to graduate, but it was also this switch flipped in year 5, right? And it was just this mode you get into, and then kind of things happen. Do you remember what did that mode feel like? Or if you could distill, what was it in that fourth year that kind of allowed you to pull it all together in 6 to 12 months?
I think in that fourth year of the PhD for me, I kind of got into this mentality of not being afraid or letting anything hold me back, and not being afraid of having tough conversations and, about my research direction, and ultimately trusting my gut. I think that's probably the biggest thing. Because for me, I was doing research in kind of an area that wasn't, my advisor's area of expertise. And, also was at the time, I was caring about this whole fact. I was it seems crazy to me that you need to label all of this data in order to be able to accurately train these models. I was there's got to be a better way, because ultimately, I wanted to bring down the barriers of AI. I wanted to democratize AI. And the fact that you needed all of this labeled data was a massive barrier to most organizations, unless you're a Google or a Meta, where you can hire an army of annotators. So it's I want to really solve this problem. And as I dug into it, I learned about this kind of part of the literature that's called active learning and course set selection, which is kind of a niche community at the time. And I was I really want to kind of go for it. And I just read all of the papers and kind of did all of the related work research and stuff like that. And I knew the space super well, but no one else kind of around me kind of knew it. So there's just this this point where it's let me just follow my gut. Let me not be afraid of having kind of the tough conversations, and maybe ignoring my advisor's advice a little bit, and just write the paper that I want to write, and kind of going for it. And it ended up working out. It ended up working out, and it gave me a tremendous amount of confidence.
You did amazing work in your PhD on active learning, kind of techniques for more efficient, data sampling and search. What's kind of the spark notes of what you ended up doing and kind of the core work of your PhD?
Yeah, so my dissertation was called Resource and Data Efficient Deep Learning. So there's kind of broadly two chapters of kind of my PhD and kind of two parts of like the work that I did, the resource efficient and the data efficient piece of it. So the first chapter on the resource efficient part, I created, we created at Stanford this benchmark called Dawn Bench, which was the first end-to-end benchmark for machine learning system performance. And then from there, that grew into this benchmark suite called MLPerf, which has now become the industry standard benchmark for high performance deep learning. And it was really amazing to see because by focusing the field in on, training time and training cost and inference cost and inference time, we saw massive reductions in how long it took to train state-of-the-art models. From when we started the benchmark, from when we started Dawn Bench and opened it up to submissions, we saw training time drop by like 400x. And then we saw training costs drop by 20x, which was amazing to see. And it's kind of fundamental to like now we see these like massive models being able to be trained because of the fact that things got so much more efficient, both at all levels of the stack, from an algorithmic standpoint, from a model standpoint, from a software standpoint, and from a hardware standpoint, which has enabled us to create and train these massive models in a resource efficient way. So that was like the first chapter of it. And in really trying to bring down kind of these barriers for AI, that resource component one was like the first kind of big barrier. And then the second piece was just the data part of it, just seeing that you needed kind of a massive amount of labeled data to be able to do anything in AI. So as I dug into, research about how can you be more intelligent about the data points that you label and train on, active learning and course set selection, I realized that all of like the research out there was kind of focused on data sets prior to the big data movement. Large scale active learning from a literature standpoint was around like data sets that had, maybe tens of thousands, maybe 100,000 examples. Like it was like people were just doing this on CFAR 10 and CFAR 100. And they had algorithms that were quadratic, which that might work when you have like tens of thousands of examples. But when you get to like modern data sets, you think of like an ImageNet event where you have like 1 million examples, it becomes intractable when you think about kind of quadratic runtimes. For active learning and course set selection techniques. So what I thought about is like,
sorry to interrupt. Just giving people a quick mental model of active learning in case they're not familiar. So basically the idea of like, how do I, rather than kind of training on, let's say 100% of my data, how do I pick the most relevant samples that are going to help my model learn the most new information, and rather than training on 100% of it. Is that right?
Yeah, that's right. That's kind of a little bit more focused on the course set selection piece, so course set selection is exactly the problem that you described. You have a massive data set already. It can be either labeled or unlabeled, depending on if you're doing supervised or unsupervised learning. But rather than training on all of that data, you want to find a representative subset that kind of captures most of the information in that data set, and then use that data set for whatever your downstream task is, like training a larger model. And then active learning is this process of intelligently figuring out which data points to label. So you start off with a large amount of unlabeled data, and rather than like, just selecting data points to label effectively at random or passively, you can actually be much more active in it from a machine learning standpoint and figure out what are the best data points to label, especially because when we think about annotating things, it's expensive. It's a huge bottleneck. It's expensive both in terms of time and cost, and active learning is trying to figure out how to be more efficient at that.
Got it. That's helpful.
So at the time, a lot of the literature was focused on what we would now call small scale data sets. So I was thinking about how do we actually scale this up to millions, potentially billions of data points. And, you have to change the algorithms from being, quadratic to something smaller. So, the first kind of piece of work was looking at, maybe we can do kind of a first step, a first pass of something that's lighter weight in order to kind of figure out what data points are the most informative. So that was this work called selection via proxy, where we basically, the nice thing about deep learning models is that they're really easy to scale down in a sense. You just change the number of layers or the number of parameters in those layers, and you got a much smaller model with way fewer parameters that's going to be way faster. And effectively, that smaller model actually can serve as a proxy. It can give you kind of a really good signal about which data points are informative for a much larger model. So we can actually use that kind of smaller model to select which data points that we should label in kind of an active learning setup, or the data points that we should train on from a core set selection setup. And then, only train the kind of larger model at the very end once we figured out the right data set. And that can actually vastly improve training time performance, as well as make active learning tractable at large scales. And then I did a second piece of work that kind of extends that in a sense, called similarity search for efficient active learning in search of rare concepts, where we create this technique called SEALs, where the whole kind of observation there is that deep learning models learn a very good internal representation, especially as we think about kind of, now with foundation models and models like GPT, these really large models that actually have a very good base understanding of the world around us. And one kind of property that falls out of that is that actually, concepts or things that we're trying to train on are actually not, spread uniformly over the space or anything like that. They're actually in a very small local area. So rather than, searching globally over, a massive data set of content to find the one example that you should label next, instead we can start, from our seed examples, because the first positive example that we have, and we can just look in that local area, because most of the other data points, the decision boundary is actually going to be fairly close to this initial seed example, because these models have learned really good representations. And as a result, rather than doing this kind of global optimization problem, we can make it a much more kind of local optimization and drastically reduce the amount of time that we need to spend figuring out that next example.
Super cool.
So that was the point of SEALs. And then it was kind of fun to see that I went from being this crazy person that cared about how do we create data sets to seeing this whole movement around, data-centric AI as people realize actually, rather than thinking about quantity of data, we can instead focus on the quality of data that we use to label and train on to bring down that data barrier.
Yeah, super, super cool. And it's cool in your papers, you proved out your techniques on 10 data sets of 10 billion images, right, from a large internet company.
Yes.
which is wild. A lot of people don't get the opportunity to work with that scale of data. And that's cool. You got to prove out your methods and techniques at that scale. So just double clicking a little bit. So super cool. Your technique was basically let's say we have 10 billion images and we want to do active learning on it in train. Let's shrink that down, much smaller model first that we can actually, and are you also shrinking the data set? So you're working with
Exactly.
a subset here, figuring out the best data points to label in this like mini experiment, and then you can scale that up to the full data set. Is that the idea?
Yeah, exactly. Like, so selection by proxy is scale down the model to make it faster to do the data selection piece. And then seals is scale down the pool of data that you even consider or even that you ever look at to find those data points.
Got it. And then in seals, like, are you doing the kind of proximity search and all of that with a latent space, or how exactly are you finding nearby examples?
Yeah, so we're doing it in the latent space based off of embeddings. And actually, this is kind of where the first initial inspiration for kind of Coactive came from, in a sense. Because, I was super fortunate while I was doing my PhD at Stanford to intern at places like Pinterest. So at first, when I was doing selection by proxy, to get large scale data, I was like, you got to go to an internet company. And while I was at Pinterest, I noticed all of a sudden that engineers were talking about embeddings and embedding vectors, which it probably seems crazy now, in 2024, but back then in, what was it, 2017, 2018 or something like that, no one was talking about embeddings.
I know. Don't you feel so old? Like TensorFlow came out when I was in my PhD, right? And we've gone through so many, it's classical ML, and then it's deep learning, and now we're in the generative world. Embeddings they totally weren't a thing like 5 years ago.
Yeah,
I mean, they were
exactly.
a thing, but the field was not substantially using them.
Yeah, true. Yeah, you had word to vec and the distributed representation of language and stuff like that, which was people were using embeddings in that kind of context. But from an academic perspective, no one was really doing research or thinking about embeddings. It was just train the model, and then some embeddings are a side effect, but who cares,
Yeah, exactly. But you were at Pinterest and they were talking about this, and what happened from there?
Yeah, what I noticed is that, embeddings were used at kind of all parts of the system. And I had this kind of, epiphany at the side. I had an epiphany at the time where I realized that this is brilliant, because effectively it's kind of this great decoupling that's happening. The most expensive part of machine learning is the representation learning piece. Getting to a representation for, kind of raw unstructured data like text, images, video, audio, get to a representation that a machine can understand, that takes a lot of time. That's what is happening in the hidden layers and things like that. And then from there, you have all these kind of downstream tasks that you want to do, things like search, recommendation, classification, and analytics. And an embedding effectively decouples those things and effectively acts as a cache. So an embedding caches the kind of all of the computation that you spend in a deep learning model into just a series of floating point numbers that you can then reuse for all these different prediction tasks. And you can train other models and you can iterate on that. And it's way faster, way cheaper than having to go back and reprocess the raw data every single time. I was like, that's brilliant. That is, my dissertation was resource and data efficient deep learning. And I was like, can't think of anything better than that. I was like, that's brilliant. But it was kind of funny at the first time, I was like, is this some weird Pinterest thing? Is this do people actually do this in production and kind of out there in the world? And then I worked at Meta on their applied CV team, and I was like, oh, Meta's using embeddings as well for search, analytics, advertising, all of this stuff. But there's kind of no systems built for it. They're kind of effectively having to build everything from scratch in order to derive this value out of their image and video data and just the content that they collect. Everything from processing the raw assets, generating the embeddings, doing all of this stuff. And I was like, that's a lot of work to do. And it requires a lot of expertise in order to do all of that work and to build kind of like those systems. But it generates so much value, in creating kind of this like embedding based, this vector based thing. So that was kind of like the initial inspiration. I was like, can we create kind of take this emerging playbook that we're seeing at all of the big tech companies and create a platform, create a system that actually creates an enterprise grade solution that any company can benefit from. And then combine that with like the fact of reducing labeling so that you can create like classifiers and fine tune super quickly. And then, plug this all into like the existing data pipelines and data workflows that people already had. And that kind of, trifecta of like data, systems, and machine learning, like Coactive is like that at the center of that, and creating a platform that makes it easy to search and analyze visual content by leveraging the recent advances in embeddings as well as multimodal AI to actually be able to, understand content and make it searchable with no metadata, no tags required, but then still give you the ability to customize it for your specific domains and things like that. And, effectively, we do all the heavy lifting, all the kind of, tough systems pieces, which I love. I love systems work and creating things that run really fast. But like, not everyone is like me in that. Let's do all of that heavy lifting so that, other companies, companies that haven't, built out or like a full ML team or an ML systems team that don't have the resources of like a Pinterest, Meta, or Google, let's enable them to be able to build on top of this, to create this kind of next wave of intelligent applications by creating that foundation, that foundation as we call it, a multimodal application platform that will enable this kind of next wave of intelligent applications.
I love it. And what are some examples of what your customers have been able to do with Coactive?
Yeah. So we see customers kind of across the board. And I kind of think about it in terms of like level of maturity of kind of the technical journey that these companies go on. So, the first kind of crawl step is being able to do search. Being able to do semantic search, and to be able to go from an image and find another image, leveraging embeddings and leveraging what we now call vector databases, or go from natural language to images, leveraging multimodal AI and kind of techniques like clip, and then everything that's kind of followed on after that as we kind of continue down this multimodal AI. So search is kind of that first piece. And with a large Fortune 50 retailer, they have all these marketing assets, and their internal tool beforehand was so bad that they couldn't even find the most like basic things. And the reason for that is that, when we think about e-commerce, or when we think about kind of retail, with the rise of e-commerce, we're making purchasing decisions based off of images and videos, but our search systems really haven't adapted. And, for enterprises, they're stuck in this process where they have to tag the raw images and videos or the raw assets either through human or machine annotations, then load those annotations into their systems as metadata, and then search based off of that. This process of tag, load, search, which is super expensive, super slow, and low cover, and like leads to low coverage. You just can't do it over all of your assets.
And is this like the employees who are searching in order to like aggregate a catalog, or it's the consumers who are searching to be able to find similar or related kind of content of like a new shirt? Give me like a white shirt with buttons.
Yeah, so we see people doing both. So we see both people doing internal search and using Coactive for that. So marketing teams, production teams, content teams, taking kind of their massive like asset, repository and library, and just wanting to be able to find things so that they can get, content out of the door, whether it be for a marketing campaign or for a release of a new show or any of these things in between. But we also see people wanting to use Coactive for, externally as well, to enable people to find clips or find, video that they're looking for more easily. And it's kind of simple, it's really straightforward. Like, you can type in natural language and you can find that specific image or that specific clip of a video in less than a second.
Mm-hmm. And so is the mental model there? The mental model there is like, if I have a website, it's actually like really hard to implement search yourself for the website. So your users can even just find like, where do you tell me kind of installation instructions, stuff like that. And so you have services like you can install kind of a Google search bar on your site, right? And they take care of the algorithms and ranking and prioritization of the content on your site. But that's just for text. So is the mental model here like Coactive does that for visual data? So now if I have a bunch of images or videos on my platform, I can enable my users to search that content in the same way that they would like search a Google search bar.
Yes, exactly.
Okay, awesome. Cool. So that's the search bit that you were saying.
Yeah. And then we also take people to full on analytics, so thinking about the full power of SQL to be able to answer questions about kind of your data. So as an example, you can imagine you're a producer or you're a part of a large media company. And what we can do is we can actually automatically generate for you a minute by minute cut sheet of what's happening on screen. And then be able to join that together with ratings data. So that you can figure out, what segments are actually leading to the highest ratings and the most engagement. So that you can more intelligently be able to actually, process that data, or you can be able to more intelligently create that kind of next episode or that next iteration of your show or your content in order to actually create something that people really engage with and love.
Mm-hmm. Amazing. So this is one of your taglines, right? Bringing context to kind of visual data, but this provides so much more color. So the basic part is just like, what is even in my large kind of visual data set, right? Like that's the start, like being able to search through it, see what's in it. And then the second piece being like, analyze kind of what's happening, how are people engaging with it, and provide. It's like the Google Analytics of visual data.
Yeah, it's kind of like the Google Analytics, but I think of it actually more like kind of like a company like Splunk. And what Splunk did to machine data, we want to be the Splunk of image and video data. Splunk, before Splunk, there was all this log data. Your servers are generating a bunch of logs that are just being saved on the local machine. And it was just so painful, and people weren't able to find kind of value out of it or do anything with it. So much so that like they referred to log data as machine exhaust. But then what happened is that Splunk came around and was able to efficiently index and ingest that data, that log data, and make it searchable and queryable, and allowed people to actually find value out of their log data. So much value that Splunk ended up being acquired for, I think it was $28 billion. And we want to do that same thing. When you look at image and video data today at enterprises, if you exclude the Googles and the Metas of the world, for most companies, all this image and video data is just sitting in cloud storage somewhere, in blob storage, more as like rather than an asset, more as a kind of a tax on the organization, just because it costs so much money to store this data just because of the sheer volume of the data. And it can actually even be worse than that because of the fact that it's just represented as blob storage, you don't even know what you have, and it can actually become a liability, especially when you think about, inappropriate content being uploaded or PII data being uploaded. It can all just be sitting there and actually be more of a liability rather than an asset. And fundamentally with Coactive, we're creating the tools to actually be able to process and understand that data and actually make it searchable and make it queryable, just like what Splunk did for log data, so that people can find value out of it. And the thing that I find so exciting about it, it's like, Splunk, again, was like acquired for $28 billion or something around that for processing log data. When we think about visual content, we fundamentally live in a visual world. And, already today, 80% of internet traffic is video data. And it's predicted that by 2025, 80% of data worldwide is going to be unstructured data, such as, video and audio files. And those predictions were made before this recent wave of generative AI and companies like yours, Lena, which have now dramatically lowered the barrier to being able to create content. So if it was a tsunami before, if it was a tidal wave before, it's a tsunami now when we think about the sheer amount of content, the sheer amount of visual content that's being created. It's this kind of massive ocean of unstructured data.
Yeah, 100%. And so if we project out, I like to often just say project out to infinity, but maybe infinity is too long of a period of time. But let's just project out, what does the world look like when Coactive has achieved your full vision?
So the way that I kind of think about, so the word coactive means, like, it's a real word. You can look it up in like the dictionary. The word coactive means to work together concurrently. And that led to our grand vision at Coactive of helping humans and machines work together. So when I think about the kind of eventual future of the world, rather than us having to type out a bunch of text or, create tables or anything like that to create something that a computer can understand, instead, we can actually naturally interact with kind of technology and machines in a very natural way. Audio and visual things, whether it be images or video of kind of the world around us, and everything just becomes very natural and unstructured. This like image and video data and audio data is unstructured data. And for the longest time, it's been kind of like the holy grail of data systems for computers to be able to understand that and to be able to work with it. And when I think about kind of the eventual future, Coactive has actually, solved that problem. That Coactive has actually enabled machines to be able to understand the visual world that we live in, such that our interactions with machines become transparent to us. You can, just say something, or you look at something and being able to process that information and actually have a machine be able to understand it without you having to type on a keyboard or give any structure to that data.
And so is one kind of manifestation of this, like we've seen a lot of the, AI wearables and, different pins that are just like recording everything. Would the idea be like, hey, I'm wearing my glasses or something that's recording the world around me? All that visual data is streamed into like this coactive, like data fabric that's making sense of it and then taking action based on like what's coming in.
Exactly. And effectively giving us superpowers.
I guess I'm curious. One of the things, so right now, correct me if I'm wrong, but you guys are doing visual plus text, right? So it's multimodal in that sense. But the world also includes audio. There's different types of visual data. There's 3D, all of this stuff. Like, where are embedding spaces going? Will we have like this massive, like unified embedding space in the future of all modalities into one? Or what's your take on how this is going to evolve?
Yeah, so embeddings will be able to process any form of unstructured data. The way that I think about embeddings is It's kind of like an analog to digital converter. It can turn like our analog world into digital signals that a machine can understand. And the future is multimodal. Multimodal AI is going to continue to develop. People are going to create better and better multimodal foundation models that will be able to combine all of these different signals and all these different kind of modalities of data into the same latent space and give us a general kind of understanding of everything, images, video, audio, all of that. And in this like amazing compressed representation, I kind of think of it as like digital DNA in a sense, because just like human DNA, you can pull like a hair off of your head and you can get like a strand of DNA, which is nothing more than a list of base pairs, but it captures, all the information that defines you as a human being. An embedding is nothing more than a list of a bunch of floating point numbers, and it captures all of the information about a piece of content. And increasingly, all these different modalities that content can come in will be able to be distilled down into the same embedding space.
Yeah. That makes sense. Something I have spent a lot of time thinking about is kind of what is the future of, like, I think the internet right now is it's designed for human consumption, right? There is, humans looking at a website and like interacting with the front end and the UI of it. But we've now, have started developing AI agents and, agents that can go and navigate browsers and the internet and our computers for us. And, they don't need beautiful front ends because they're just machines. They can in fact, the UI is a limitation for them, right? That they have to learn how to navigate these complex drop-down menus that when really you can just feed them a dictionary or a list and they could do just fine. How do you think about and in many ways I've thought hey, the internet of the future, the internet for AI agents should really just be this embedding space, right? Where I send my AI agent to Amazon.com and it's just an embedding space that my agent goes and kind of interacts with and traverses and pulls out information and then reports back to me. How have you thought about the future of the internet as we move to AI agents, and how does Coactive build for that future?
Yeah, it's a super great question. And I love it. I can totally see that the internet just becomes kind of it almost kind of goes back into its origin in a sense. It's kind of just a networking thing. And you have a bunch of signals that you can tune into. And those signals will transmit kind of information in all forms of different modalities. And it's kind of funny because I lived through, or, I got to see a glimpse of the future of in a very specific area, what happens when everything becomes automated and more algorithmic. And that space was in finance. So I took a kind of a random turn. I took a gap year before doing my PhD, and I was working in algorithmic trading. And at the time I didn't really truly appreciate it, but trading is kind of ahead of ahead of the rest of the world. It's kind of already gone through the transformation of AI and algorithms, because it used to be in order to trade on the stock market, you as a human being had to be sitting in the New York Stock Exchange and raising their hand to buy a share of some company, and it was literally pieces of paper were flying around, and you needed to have a human being. It was humans interacting with other human beings. But over the course of a few decades, it went from the New York Stock Exchange being packed with people to becoming a ghost town. Where now, most of the volume that happens at these exchanges is actually algorithmic. You have AI algorithms that are tuning into a bunch of different signals, different securities and, different assets, whether it be like equities, commodities, or futures, like all these different assets. And then they kind of, you unify that interface for a machine to be able to understand and interact with the global world of like all the different things that you can buy in the stock market. And then it's algorithms talking to other algorithms. And like, that's the majority of what happens in the stock market. And then like the people that were in the pits, they're gone. But what has happened is actually now more people are actually able to trade in the stock market. Like you and I, we can go and press a button on our phone and be able to trade like a stock, which is kind of crazy. It used to be you had to like pick up a phone to call a guy to like go and trade like a stock for you, because that guy would then go and talk to another guy, and then come back, and then like you're like a trade would happen. But now that's all happening via algorithms, and instead of us being like just sitting there in that whole relay, we get to enjoy kind of our everyday life, and you can like pick up your phone and like buy whatever share you want.
Yeah, that's such a good point, and it's so true. Yeah, the financial world has kind of like seen this play out, and like now the rest of the world and consumer transactions and maybe even logistics and all these parts of the world are eventually going to go in that same direction. Okay, one last AI question before we switch gears here. I always just love getting people's take on this. Do you think we have developed AGI already? If yes, why? And if not, how will you decide once AGI has been created?
It's so hard to define kind of AGI in a sense that I feel like it's like levels, just like how you have like levels of autonomy, there's kind of levels of AGI. So I think we've gone to a world, when we think about kind of these large models now and things like that, I can see the argument that they're like some level of AGI in a sense. They can understand a lot of different things. They can do pretty good performance on a wide variety of tasks, especially, if that task is formed in a way that they can understand, they can go and interact with the world in a way that can be hard to distinguish between kind of a human and a machine. So in that sense, we've partially got into, a certain level of AGI. But I don't think that we've really got into like, the like kind of scientific or the singularity version of AGI in a sense, where you have autonomous agents fully being able to kind of reason and interact on their own without prompting from human beings, in a sense. That's how I think about kind of like true artificial general intelligence, thinking of AI in the like kind of truest and kind of like original sense. Artificial intelligence, like as a field, was the North Star, was to be able to create an intelligence that like acted indistinguishably from a human being. And I don't think that we're there yet, partially because, again, you need kind of like the right prompting from a human being. There's not the full level of autonomy. Also, when we think about kind of interacting with things in the physical world, that's also kind of a limitation of like AI in a sense. It's not fully kind of like human intelligence. There's also like, when we think about human intelligence and certain things, certain concepts that we can kind of pull together and communicate, that I think are still really hard for machines to do. So they've come a tremendous kind of way in that time. But so I think we're at a certain level of it, but we're probably not at like, the level 5 of AGI, like in a sense. And I think that'll it'll take us time to get there. But I don't think that it's like it'll take us an unreasonable amount of time. I think that it'll actually happen, probably within our lifetimes. And then it's kind of interesting to think about like what the world will be like in that kind of moment. I'm of course like a tech optimist in a sense. There's this one book that I love. It's called The Three Body Problem. And it actually talks about the kind of exponential growth of technology, where you just see kind of like the pace of technology and adaptation kind of get faster and faster and faster over time. And like, it gets kind of like just ridiculous. By book one, it's kind of like something that you and I can understand. Book two is my favorite. It gets to kind of like some really crazy philosophical answers to some paradoxes. And then like, book three, it like hurts my brain because like technology has gone so far in advance. So, and I think that we're actually living through that kind of right now, this exponential kind of growth in technology, just if we look at like over human civilization, how fast things have happened. I mean, even thinking about like, as we were talking about earlier, Lena, just thinking about AI and the progress that we've seen. Like, I remember at the beginning of my PhD, it was like, there was an explosion of different frameworks that were happening. You had, of course, like TensorFlow, and like PyTorch was the new kid on the block. You had Cafe 1, Cafe 2. You had Torch. That was like, not PyTorch. What was it? What language was it? Lua or something like that was written in? And like all of this explosion. And in the course of like a couple of years, we saw that consolidation happen to just being kind of a few kind of core languages. We also saw this kind of whole movement around deep learning just happened so fast. Like it was 2012, like the first like deep learning kind of model broke through with AlexNet. Then, 3 years after that, we had ResNet, which like became kind of the first production model, I would say, of like, of deep learning. And then was it 2-3 years after that? I think we had like GPT-2 and Clip models were created. And then now, kind of 5 years after that, we're at these we have ChatGPT, we have these kind of large language models that are creating these kind of super general models that are like everyone's co-pilot and assistant. We have like agents that are able to actually understand the web and understand the digital world. And it's amazing to see just kind of how much progress that's happened in like just our short kind of time in AI and just in academia. And it's crazy to think how much is going to happen in the next, 5 to 10 years.
It's wild. I really like the mental model of like levels of it. And I wonder if I agree, we've certainly not reached the AGI level of autonomy and like AI being able to go and be independently trying things in the world. Though I wonder if that is more an issue with the tools we have. Right now, it could be. I'm not saying it is. It's like a brain in a vat, and it just doesn't have arms and limbs and like tools to go and act on the world, right? So maybe that's more of the limitation rather than the core reasoning, which I don't know. But I want to switch gears. This is something that always interests me of like how other people think about it. Yeah, go ahead.
Wait, Lena, before we switch gears, can I tell you one thing that I'm like super excited for? It's very nerdy, but I'm excited. I think it's going to be like in the next like 2 to 5 years time frame. But to your point that like we have this like, these AI models that are like brains in a vat in a sense. I think the first place where we're going to see kind of AGI in a sense is actually video games and like, I think it's, so I was a gamer, as I said at the very beginning, and I can't even imagine and fathom like video games in like kind of 2 to 5 years from now, where you're going to have this kind of like never ending story that just like dynamically evolves as we think about kind of all these like AI agents both being able to like dialogue and interact with us. And then you put on like a Vision Pro or something like that. It's in 3 dimensions, and it's like you actually get to live in a fully digital world, a fully virtual world with all this like autonomous agents kind of interacting with you. And I think that's going to be like I can't even imagine that experience, but I can't wait for it as well, because I think it's going to just be so unique and different.
Yeah, it's like that movie. I don't remember what it's called now, but Ryan Reynolds. What's it called?
Ready Player One, but I'm not sure if...
No, not Ready Player One. This is like a more, I don't think it's based on a book, but maybe it is. But Ryan Reynolds stars in it, and he is like he's an NPC, but then he becomes
Oh,
sentient.
yes.
Do you know what I'm talking about?
Yes,
Okay.
I know.
I
It's
forget what
like,
it's called.
oh, that's going to bother me now. I'm going to like, after we get done with this podcast, I'm going to go and look it up. I can picture the trailer for that movie and everything, which is so funny.
Yeah. But yeah, basically that. I agree. I think like these isolated virtual worlds are where we'll see AGI first. I completely agree. And it's like, I think movies are going to start turning more into video games. So you'll be able to kind of interact and like remix kind of a movie you're seeing. And then video games are just going to be this like, can't even imagine, right? Whole new world of an experience that doesn't exist today.
Yeah, exactly.
I am just super curious to hear about how you think about this and kind of the mental strategies you've kind of developed over time. So you are a Black man in engineering and also a startup founder. I am a woman in engineering and also a startup founder. Like both are not that common. How have you thought about this in your own life? Like specifically, like when you go into a room and you're kind of the only like Black person there, do you notice it? And if you don't notice it, that's interesting. If you do notice it, what's kind of the self-talk that you give yourself about it?
Yeah, great question. I definitely notice it, because like ultimately, my mission in life is to demonstrate that regardless of where you come from, you can be successful. So whenever I walk into the room and I realize I'm like the only one or like, one of just a small subset, it's a reminder that we have like a really long way to go. Especially in the spaces that you and I are in where there's just like not that many of us, in like startups and especially deeply technical AI startups. So I definitely notice it. I think the self-talk that I do is because so first off, it sucks, it sucks when you're like the only person in the room and like, you just can't like, you feel like alone in a sense, there's no one else that kind of gets it. And like, you wonder if people actually understand you or are they reading into you in kind of another way. What gives me courage or what motivates me is the fact that, by showing up in these spaces and by being myself and doing well, I just think about like all the people that will come after me, all the people that are already inspired, by me, and just like that motivation, that fact that by me showing up, that's going to help others, that's going to inspire others, that gives me the motivation and the courage to do it, day in and day out. That was the same thing in the PhD. I thought about dropping out in the PhD. I was at the time, I think I was the only Black CS PhD student in the department when I started, out of like 250 PhD students, and I believe I was the first Black CS PhD student to graduate from Stanford CS program in like close to like 20 years or something like that.
Wow.
And it was really tough. It was really, really tough. In like the third year of my PhD, I was like, man, this really sucks. Like, why am I here? Why am I doing this? But the thing that kind of kept me going was just the notion that, I knew people that were looking to me for inspiration. I had helped people with their like statements of purpose that like wanted to go into the PhD, that believed that they could do it. Because I just was showing up every single day. And I still had energy left in me. I still had, the will to like kind of go and do it. And I knew that I would regret if I gave up because of just like, not because of like me, like we're super fortunate in the fact that like, even in our, like the worst outcome, we'll still be okay. We're like super highly employable and stuff like that. But what motivated me was to just think about everyone else, just like how impactful that would be and how that would like, help so many people kind of follow afterwards. I was like, I'm going to, that's why I like stayed for that other year and decided to give it my all so that I could just know confidently that I had no regrets and that, I gave it my all and did it. And was kind of amazing. It was amazing to see that, I graduated, and that also now in like the CS department, the PhD program, and the CS department at Stanford, there's over a dozen Black CS PhD students, which is incredible to see. And now as like a startup founder, and when I go into rooms, it's like that story is playing out again, where, I'm the only one, or just one of a small subset. And actually, when I first started Coactive, I actually created this like Black founders group where we just did like monthly like Zoom calls. And we did that for 3 years. Effectively in this past like February, we did our first Black Founder Summit to actually get people together. And it was just amazing to see, just like so many people going after it. And I think that, for both of us, like, like we're alive at such an awesome and incredible time where I think that we're going to actually see very like massive change in terms of representation in the rooms that we walk in, and in the kind of journeys and the path that we decide to go down. And it's really awesome. It's really awesome. And I feel like, honored, and proud to be a part of this change and this wave, and to prove that like you can be different and succeed.
Yeah. This is so interesting. Okay. Let me tell you kind of my self-talk, and then I'd be so interested in seeing if it's like the commonalities and differences. Cause I think I have ended up approaching it maybe from a different angle. So let me tell you a story that kind of illustrates it. And so for me, at MIT, I was co-director of this group called MIT Hacking Medicine. And at the time, my co-director was also a woman, Priya Garg. She's amazing. And we were going to someone like pretty high up at MIT, kind of asking for help and more resources, because like so much inbound was coming to our organization, and we like just needed more help and more resources to kind of meet all the demand. And I'll bleep this out of the podcast, but I'll say the name now. So it is. But we went to meet, and he basically, like, the TLDR is I felt like he just kind of like blew us off in that meeting. And, didn't really like, was nice enough, but like kind of blew us off and like didn't really offer the support. And then my mind went into like, oh, is he treating us this way because we're women? And, I like actually like felt like really like not good about it for a few weeks. And then I don't know, like this switch happened, and I was like, so what if it is? Like, there's absolutely nothing I can do to change it. And I am actually not my best self when I am thinking about the fact that I'm different because I'm a woman in like often like male dominated fields. So actually since then, I've like taken this approach where I like really just like almost consciously ignore it. And even when I find myself like noticing it in rooms, like, oh, I'm the only woman in here, I'm like, it's kind of like meditation where you can control your thoughts. It's like, let me not think about that, because it doesn't help. What's going to help like society as a whole is to have role models and examples that are equal and representative. So me doing my part means me doing kind of the best I can be as an individual and rising to kind of my full potential. And I can't do that if I'm like not at my best and kind of, thinking about how I'm a woman and no one else is a woman in this room. So it sounds like a different, I'm curious to get your reaction. Have you ever had that mindset? It sounds like for you, it's actually very motivational, and kind of, it's like, to realize that you might be kind of the only Black man in the room, and like you want to do well, and kind of like you're standing for something bigger than yourself, and that super motivates you. But yeah, curious to get kind of your reactions to my self-talk and mental model.
Oh yeah, 100%. I've definitely felt that before. I think it's kind of interesting. I kind of have gone through these different stages or these different evolutions in a sense where like, I think definitely during the PhD, I felt that, being like the only one in the entire CS PhD program. It got to me at first, it felt like, I had a spotlight on me and that, I didn't belong. And then like, also it felt like I had 3 extra jobs effectively, it's like, first I'm a PhD student, which is like tough by itself. Second, I have this spotlight on me. Third, I have to like kind of go above and beyond to like go and find my sense of community. And then, like on top of that, then like, there's like, I'm like the person with the spotlight that has to do all the outreach and like solve the problem as well. And it was just like a ton of weight. It's like this invisible weight on like, kind of like your shoulders in a sense. And similarly to you, I felt like I was being kind of held back and I couldn't do it anymore. Or like that I was like, it was holding me back. And that's what happened actually, I think in that kind of going from my 3rd year to my 4th year of the PhD, where I was just like, forget about all of that, just like take that weight off of my shoulders and just be who I am. And let's see where that goes. Like follow my gut and go through that. And I think the thing that then happened is that it worked. Like it worked. Like I went from 0 papers published to 4 papers published. And then that bet turned into courage for me. And now that courage has turned into to confidence to keep going and to do it now. It's kind of almost like I have this like mental cookie jar, like now in my head where I'm like, yeah, I've done this before. I've gone through this before. I've dealt with this before, and I've seen the impact that has had not only on me but on other people. And wanting to do that again is the thing that, I now focus on, and that, I've gone from from just trying to survive to thriving.
Yeah, I love that. That's a super cool journey and how it took you kind of just focusing on being the best version of Cody and then succeeding. That and then the confidence that came from that to then be able to kind of think broader in community and like the example you're setting. I love that. Okay, last question before we wrap up. So one thing I find super inspiring about you is kind of how you put out there these big audacious goals that you have for yourself, for your company. Some examples include, you said, I want to build $1 billion company. I want to be president of the United States. Done half marathons, like powerlifting. Has like goal setting always come naturally to you? And if not, like when did you start doing it? And what's your process for goal setting today?
Oh, super, super great question. So it's not something that I like naturally had, kind of, I mean, back in, growing up, like, I wasn't like, I was not like a particularly special kid, in a sense. I was just like living life, or like, not just like, in kind of limbo. But kind of what happened is that, with my family and everything that I saw, I was just like, I don't want to live this life. I don't want to be stuck in this small town in South Jersey, struggling to be able to afford even like basic things like toilet paper. And goal setting emerged for me out of survival. It's just like, I got to get out of this place. So like, let me come up with a goal. What's like the highest probability goal for me to just get out of here, So that was like going to college was kind of that first goal for me. And then what ended up happening is that, I did that goal, and that goal gave me, just a little bit of confidence to set another goal that was a little bit bigger in a sense. And it's kind of funny, like, yeah, like it's kind of funny. Like back at MIT, I still remember it was like you would start the week and you'd be like, I don't even know how I'm going to get through this week. I got like 4 P sets are due. I got 3 exams and 2 labs that are due this week. Like, how am I going to make it to like the weekend? But then like somehow you figure it out and you get through 1 week, and then you have like a month that's like that, and then you're like, you get through that tough month, and then you get through that tough quarter, then you get through that tough half, and then you get through that tough year. And you finish your freshman year and sophomore year, junior year, and then after 4 years, you've graduated. Like after 5 years, I'm doing something that I never imagined. I'm applying to PhD programs, and it's kind of like building a muscle. 1 rep at a time, starting with these kind of really small goals to just give you the confidence to take a bigger bet, to give you the courage to take a bigger bet. And then you just kind of keep doing that, like building a muscle and going to the gym of just like setting these kind of bigger and bigger, kind of more audacious goals. And then it almost just becomes kind of second nature to you in a sense. You're like, it becomes like kind of, it just becomes so natural in a sense. It becomes kind of almost like a reflective process. I think about it, and I take the opportunity to kind of reflect about, what in my life do I like versus that, like things that I don't like. And then I think about how can I set goals to, take a step in the right direction to become 1 step closer to the ultimate person that I want to be. And that's kind of, goal setting for me now.
And do you have a formal process? Is it like quarterly? Is it yearly? Is it every 5 years? Or is it more ad hoc?
It's more ad hoc. It's kind of an everyday thing in a sense. I mean, I guess I set goals that kind of all sorts of different time lengths and levels. It's like every morning I wake up and I like look at my schedule, I look at my to-do list, and I'm like, what is like the one thing that I need to like get done today, in a sense, and like what can I put off or wait and things like that. And because especially as as a founder, there's like a million things that like, kind of attack your attention and attack your time. So I do that kind of one thing a day. And then I think about like, what do we need to do like this month or this quarter or this half? And like, at any point in time, I have kind of like, what are my top 3 kind of goals that I want to accomplish in the company? It's like, in the fall, like, last year it was like, we need to do sales. We need to hire a head of engineering. We need to hire a head of product. And then I'm like, cool, these are like the North Stars until like one of these things gets done. Then I add a new goal to it and things like that. And then of course I have like my big kind of like, goals that are measured on the order of years, like starting $1 billion company, or on decades, like become president of the United States. That kind of serves as those guiding lights to kind of help and kind of trickle down into the other goals I set, even on like a daily basis, or on sometimes it's even on an hourly basis. It's like, I just got to get this one thing done or something like that, or I just got to make it past this one meeting, or something like that. So
amazing. I love that. Thank you so much, Cody. Anything you want to ask of the audience? Like, where can they stay up to date with you, and any asks for folks listening today?
I mean, the biggest ask is that, I would love to have more folks follow on the journey, because just having the kind of support and confidence, that's the thing that gives me fuel to keep going. So, follow Coactive on LinkedIn, follow me on LinkedIn, and, subscribe to be a part of the journey. And there's been so many times where it's actually just kind of a nice message from someone, like them going out of their way, that like gives me the courage to be like, okay, like people care. Like, it's like because you go through like really tough days, like really crazy things happen, and you're like, what am I doing? And sometimes that random kind of nice message from someone could be like the little thing that you need in order to be like, hey, I got this. Like, let's keep going. Let's go and like show up, day in, day out, through the ups and downs. So that's probably the ask I would have to anyone listening. If you want to help me out, subscribe to the journey, and send a nice note.
Amazing. Yeah, I will link to Coactive and your profile in the show notes. Thank you so much, Cody. This has been absolutely amazing. And until soon.
Oh, thank you so much, Lena. Thanks for having me. This was so much fun. The time flew by.
I know. I honestly feel like I could talk to you for hours and hours.
Oh, it was so much fun. It was so much fun. We gotta do this again. This is awesome.
For sure. Yeah. Well, we can do a part 2 as well.
Yeah, totally. That'd be fun. Like checking in a year to see kind of as things evolve and whatnot.
Yeah, it's such a joy to watch your journey. I am excited to vote for you for president one day. I have to become a citizen first, but I will do that.
That's so awesome. Thank you so much. And also, I'm not planning on running anytime soon, so you got plenty of time to do that.
Thanks for listening to The Edge of Infinity, an AI podcast. You can find all show notes, transcripts, and resource links to all of our episodes at blog.infinity.ai. I'm your host, Lena Avancini-Colucci. You can find me on Twitter at Lena_Colucci. That's LINA_COLUCCI. Thanks for listening, and until next time.